Hello guys, so today I'm going to explain you how can we solve this problem from August Circuits. This is from Hackerearth monthly challenge, and this is a really nice problem. It's based on digit DP, and today I'll show you how can we solve such problems similar to this. So let's quickly read the problem statement. So we are given a range L to R, and what we need to find is the number of k special numbers in this range. A k special number is a number whose all digits are multiple of k. So for example, 26 is a two special number. Why? Because all the digits in 26 are multiple of 2. Similarly, 63 is a three special number. So basically, for any number to be a k special number, all the digits in that number should be multiple of k. And the constants here are something which makes this problem even more interesting. So the number of test cases would be 10 raised to the power 5, and the range in which we need to find the k special number would be 1 till 10 raised to the power 18, and yeah, the k special can be 1 to 9. So yeah, let me try to explain you how can we solve this. Alright, so basically what are we given? We are given a number R and basically L and R. So in most of the problems similar to this, what we try to do is try to find all the numbers from 1 to R, and then we'll try to find all the numbers from 1 to L minus 1, or maybe even L, and then we try to subtract these two numbers, and this part is our answer, right? So this is what we are going to do. Basically, we'll try to find all the k special number from 1 to R, alright, and then we'll try to find all the k special number from 1 to L, and then we'll check whether L itself is a k special number or not. If it is not, then we can directly subtract this whole number from here, and we'll get the amount of k special number in between this particular range. Otherwise, if this L is special a number itself, then the answer would be same, but one more, because we are also including this L to R is inclusive. That means we need to consider L as well as R, and if we would subtract this 1 to L, then we are eliminating L as well. But if we will separately check whether L itself is a k special number, then we'll just increase the answer by 1. So yeah, that is what we are going to do. And now let's try to see how can we find all the k special numbers from 1 to a particular number, let's say for example R. Now let's try to look at some observations that we can make. So here it is given that k can only be from 1 to 9. Alright, so for example, if k is equals to 2, then what are all the digits are possible in a particular number? So it can be 0, it can be 2, it can be 4, it can be 6, and it can be 8. Alright, and if it is 1, then all the numbers from 0 to 9 are possible. And if it is 3, then only 3, only 0, 3, 6, and 9 are possible in a particular number. I mean, these are the digits which are possible. Similarly, if we go for if we go for 5, for example, then there are even lesser number possible, that is 0 and 5 only. And I think from 5 onwards, there are only 2 possibilities for each number, each k. That means if we consider 7, let's say, then only 0 and 7 are the only digits which can be included in a particular number. All right, so for example, even for 9, you can see that 0 and 9 are only possible. For 4, it was 0, 4, and 8. So if we can just simply store this particular information, because we are going to use this information. And what this means is, basically, for example, if we have, let's say, we need to find all the numbers which are of length 1 and k special number. Let's say for example, if you want to find all the numbers which are 2 special, and let me just write it down so that we can, yeah. So basically, if we want to find 2 special number and the length that we want is of 2 length, all right, all the numbers which are of 2 length. then on this particular place, what are all the digits that we can place? We can't place 0 on the first place, right? Because if we place 0, this would be a one digit number, one number of one length. So we can only place this, basically instead of 5 we can only place 4 numbers here. All right, so we can place 4 number here, and in this case now we can put all the possible numbers, that is 5. So total possibilities that we can have for a 2 special number of length 2 is equals to 4 multiplied by 5, that is 20, right? Because we can choose any number and then we can choose the other number from here. And now let's see, what if we were to choose, let's say for example, 3-digit number. So here we saw that we could have got 20 such numbers, and in this case what we can get is we can still place all these 5 possibilities here if we were to choose only two special numbers. So this would make it overall 100. I mean, for the three length, after for 2 special numbers of all the 3 digits numbers, I mean how many numbers we can find for all the 2 special numbers of length 3, and that is equals to 100. All right, so similarly if we were to find some, let's say for example, 4 digit numbers, all the 4 digit 5 special numbers. Yeah, I think that's better way to say it. So all the 4 digits 5 special number. So here we can say that instead of 2, we can, in the first place we can only place one number, that is 5. So that is 1, and then for all the 4 remaining 3 digits we can place either 5 or 2. So overall we can have 8 such numbers of 4 digits which are 5 special numbers. So why are these information important? We are going to disclose this in a moment, but for now I'm just trying to understand these are the observation that we can get from the constraints that are given to us. So basically if we were to select all these numbers, let's say for example, for now we are not considering any particular number, like we're not bounding our we are not limiting. So for example, if we were to find all the numbers up to this number, let's say 1 4 2 6 5, this is just an example. So as we can see that if we are to find, let's say for example, all the 2 special numbers up to this number, then what one particular observation we can make is that this number is of 5 length. All right, and what is for sure we can get is all the numbers for 1 length, all the numbers for 2 length, all the numbers for 3 length, and all the numbers for 4 length. I mean all the numbers which contains only 1 digit or 2 digit or 3 digit or 4 digit, these are all the numbers which will always be included. Alright, so with this particular information we can always find all such numbers. So for example, let's say if we were to find all the count of numbers which are 1 digit and they are 2 special, then in the place of 1 we can only place 4 such numbers. So for 1 it will be 4. All right, now for 2 we just saw that we can make 4 multiplied by 5, because on the second place we can place, here we could have placed only 4 and here we could place 5 such numbers. So this would be 20. For 3 digit numbers it can be 100, and for 4 digit number it can be 500. So 500, 600 and 624 are such numbers which we can make definitely up to this number. Now further we need to find how many 2 special numbers we can find which contains total 5 number of digits. So this is something which is more interesting than all of this, and this is what I'm going to explain. Now I hope that this part is overall clear to all of us, and now from now onwards I'm going to explain how can we find number I mean this k special numbers which are of the same length as this particular number, that is 5 length. and I'll show you why this is more important than this particular part. Alright, so I'm gonna continue the second part, that is to find all the two special numbers of length 5, that means of or all the 5-digit numbers which are two special numbers. So I'm just gonna explain the logic on this example. We can extend this to any particular k special number for any given number, any given number up to 10 to the power 18, which is our, yeah, the constraint. So what are we going to do? We are going to form all the possible numbers, that is all the possible number recursively. That is, what are we going to do is we are going to place all the possibility on one particular number on one particular place, and then try to find all the possible how many possibilities are occurring from here onwards. That is, let me first try to increase this one to 7 instead, because 1 4 won't make much of sense here. I'll just explain why I changed it to 7746. So let's see that we have 74,625, and we want to find all the two special numbers up to this number of length 5 only. So first thing that we can do is we can try to see what all the numbers we can place in place of the first digit. Let me just get rid of it. So here we have 5 digits, all right, and we'll try to recursively fill these digits one by one. So for 7 we can only place either 2 4 or 6, all right, because after 6, if we, let's say, if on the first place if we put 8, and definitely these numbers are going beyond the range that the limit that we have, so we cannot place 8, and we cannot place 0 because this is the first place, right? So 0 is not allowed, only 2 4 and 6 are allowed. 7 is also not allowed, 8 is also not allowed, which was a part of 2 as well. So what are we going to do? We are going to try with all the possibilities here. Like for example, we can try with 2, we can try with 4, or we can try with 6. Now what happens when we try with 2? So when we try with 2, we say that we can go on the next number, and here we are now free to choose any numbers on any place. On each place we are free to choose any number, because the previous number, the previous place itself was below this number. So what I'm trying to say, we are not enforced to choose any number below this particular digit as we had chosen here. We saw that 7 is something which we cannot go beyond, but when we chose some number below this particular 7 number, then on all the places onwards, from for all the places for 1 onwards, we can choose any numbers. You can see for 2, for 4 and for 6 as well. But now what will be the case if instead of 7, let's say for example, if this was only 6, now still for 2 and 4 we are free to choose any numbers on these places, like any digit, 0 2 4 6 or 8 only, because this we need to find the two special numbers, so we will only place those digits which are multiple of 2. So here we could have placed 5 number, or 5 here, or 5 here, or 5 here. Similarly on this number also we could have placed all the 5 possible numbers. But now when we chose 6, now we know that we had chosen some number which is telling us to not freely, which is trying to bound us, so that we are not now free to choose any number. So for example, for 4 we are in the similar situation as we were in case of the first place, because if we go and choose 6 and 6, this will go beyond the number 64,000, all right, because any number here we will place, even if we place 0 0 0, this will be more than this number, so we are not going to consider this particular possibility. So now we know that we can only choose either 0 or 2 or 4. Right, so 3 places, yeah. And so again for 0 and 2 we would be able to choose all the possibilities here. All right, but when we choose 4 here, again we are limited to choose only up to 6 for this case. That means 0 4 0 2 4 6. Again for 0 to 4, for this third place we can place anything, but for 6 we are bound to choose here only 0 and 2. And when we choose 0 we can place here 0 2 4 8 anything, but when we choose 2 here we have to place only numbers up to 5. That means 0 2 and 4. So yeah, I think you got the idea here, and this is what we are gonna do. So as you saw that we need to know from, there has to be something which need to tell us whether we are bounded or not. That means I will say what I'm gonna use is a particular variable called tight. This tight will tell us whether this is tightened or not. That means if we are free or not. If this tight is equals to 1, that means we have to choose only the number up to this character, I mean this digit at this place. If not, then we can go for all the number from 0 to 9, considering all those digits which are multiple of k. K means for example 2 here, and this is what we are going to recursively solve. And just given you an idea that this is recursively, I mean we can solve this recursively. If you try to draw the decision tree, you will see that there are overlapping subproblems, and hence I'm gonna memorize them, and so that we can try to solve this in limited time. Otherwise as you can see, in the worst case each place can have at max 5 digits, and there are 18 such places. So 18 is 10 raised to the power 18. So because each number can be as big as 10 raised to the power 18, that means the length of the number can be 18, and we are only considering this particular logic for the for that particular length, which is the length of the string or length of the number. So as we can say that on each place we can place 5 numbers, so the complexity will be 5 raised to the power 18, which is not going to pass unless we memorize it. So I think I'm able to explain, I was able to explain you guys. Now let me jump into the code, and I hope then it will be much more clearer. So yeah, this is what our code looks like. I've done some pre-calculation for the part which we discussed, that this is something which is independent of I mean what I've done is I've tried to calculate how many numbers each how many digits each number can have. For example, for I'll just store for 1 how many how many digits we can have. So m of 1 would be 10, m of 2 would be 5. I mean here we can see 0 to 9. I'm iterating over and checking what if it is divisible by k or not. If it is, then I'll add one more, otherwise I'll just add 0. So this m map will store, this is defined here, so map will store all the possible numbers that we can have for any particular k. Then independent dp is something where I'm storing for the first part when I'm going to calculate all the numbers for a particular k and of a particular length. So for example, we saw that for example for all k, let's say for example even k equals to 3, and if we just are interested to find all the numbers of length 1, then it will be m of 3 minus 1, because we saw m of 3 would give us 0 3 6 9, but we cannot place 0, that's why m of k minus 1 for length 1. Now for length 2 onwards, what we were doing is for previous length multiplying the value of m of k. So for example m of for length 2, what we were doing is 2 for length 1, what was the answer? That the answer was 3. In case of 3, m of 3 is 4, so m of 3 minus 1 is 3, and for the length 2 it will be 3 multiplied by 4, so 12. Now for next number on next length onwards, it will be 12 multiplied by 4, that is 848, and then so on. So this is I'm calling a independent dp, And then what I'm doing here, as I said, that first I'll find all the k special numbers up to r, and this is what I'm doing here. So all the k special number up to r, that is, I've stored the length of the r in n, and I'll iterate for all the lengths from 1 till n, not till n, just n minus 1. And then for the last case I am going to recursively find the answer using dp. So as I said, for the first digit, that is for here, I'll try to find all the possible number, that is 246, starting from 1, not from 0. So that is what I'm doing, from 1 to all the numbers up to this particular digit. And if this is not divisible, then I'll continue. That means for 1 to 9, 1 to 6, there are, for example, 4 and 5 as well, which we shouldn't consider. Oh, sorry, 3 and 5 as well, which we should not consider, because 3 and 5 are not divisible by 2. So now this type will tell us that what would be the next, what would be the state in the next recursive call. So here, if this I itself is equals to the digit at this particular place, that means if this itself is 6, then we should tell that for the next numbers we are bounded by this limit. So this is what type is telling us, and n is the length, yeah, and k is the special k number that are given to us. And let's now look at the function here. This is what is we are using the dp, and I'm trying to just, this is the base case, that if we have reached the length of the, if IDS is equals to the required length, that means we have reached the valid number, we have formed a valid number. In that case we should return 1. Otherwise I'll initialize our answer with 0. This is just the memoization, and I'll check what is the limit that we need to have. So for example, here, as I said, here we could have placed any numbers if we would have chosen 0, 2 or 4, 2 or 4 here. So if the limit is, if this type is 1, so for example, if type is 1, then only we are bounded to we are limited to choose only up to this particular number, that is up to 4. And if type is not 1, that means we can choose all the numbers from 1 to 9. And then here again we will continue, we will not consider if this is not divisible by k, and if it is divisible, then we will find the new type, and new type will be based on this number. I think I have explained this one enough, so you can figure it out. Then I'll recursively try to find the answer for the next place. And here I'm doing the memoization, and I just this is what I'm doing for finding all the numbers up to r. Then I'll do the same for, and keep in mind that we are going to deal with a different string now, or different number. And I just forgot to mention that because these numbers are very big and we anyway need to consider them as a string, so I have anyway got the input for L and R as a string. Now for calculating L, we need to take care of reinitializing this dp table, because we are going to deal with a different string, and this is something which I missed in the beginning. Then what we need to also do is we need to start with this again for find the answer for all the numbers from 1 to L. The same logic, exactly same logic. And as I said, L itself can be that particular k special number, and if it is the case, this check is very obvious here, that I'll just check for each digit in this particular string, and if any of them is not divisible by k, then means this is not a k special number, and if it is, then I'll just decrease answer 2 by -1, and then here I'll subtract answer 1 minus answer 2, and that will be our answer. So yeah, I hope I was able to explain it properly, and thanks for watching this video, guys. If there is any comment or feedback for me, please let me know in the comment section, and do subscribe to my channel if you haven't already. Thanks.